Alright, in section 10.3 we're going to be talking about polar coordinates. Okay, so now the way we're going to be able to describe a point, say this point right here, we're going to use the radius r and this angle theta right here. So this point right here, r comma theta, that is a polar coordinate. Now this is not the x-axis anymore, it is now the polar axis. This is not the origin anymore, it is now called just the pole. Now your radius in a polar coordinate can be positive or negative in this case. Okay, so this is what a polar grid would look like. It's just a bunch of different circles. Okay, so you'll have different r's for every circle. So for this circle right here, the radius is r. For the next circle, the radius is 2. And you just keep going out. This radius would be 3. Okay, so to find a coordinate, say this one right here, well, I know that I'm on the second radius, but then look at what angle I'm at, 45. So at that point, that would be 2, 45 degrees. Okay, so say we look at this one. Plot the point 3 pi over 2 on the polar grid. Okay, so 3 pi over 2. Well, there's radius 1 right here, radius 2, here's radius 3. That's where I need to be. So somewhere on this circle right here, and since our theta is pi over 2, same thing as 90, well, here's pi over 2, so that has to be this point right here. Okay, now if you look at how do you deal with a negative radius? Well, what you would do is, first off, you would kind of ignore that negative there for a minute. And we'll go ahead and change this pi over 6 to degrees. So that is the same thing as 30 degrees. Okay, so 30 degrees, if this is halfway between 0 and 90, this is a 45 degree right here. So 30 degrees would be about here. Okay, so I'm going to go to R is 2. So here's R is 1. Here's R is 2. So at this point right here, that would be 2 30 degrees. But since this is negative, once you plot the positive version, you just go straight across until you're back on that circle. So then that would be a negative 2 and not a positive 2 anymore. Okay, if you compare the two, this is where our positive 2 was over here. And then once we have a negative, you just go straight across from the first quadrant to the third quadrant. And this is where our point should be. Okay, so if we're going to convert from polar to rectangular coordinates, these are the formulas that I would need. Okay, actually it's really just these right here. Now that's if you're starting at polar and you're going to rectangular coordinates. So like this one, convert 3, 90 to rectangular coordinates. So they're saying that r is 3 and my theta is 90. So my rectangular coordinates, that is x, y. And we know that x is equal to r cosine theta because of this right here, r cosine theta. So x would be 3 cosine 90. Okay, on my unit circle, 90 is right here. That point is 0, 1. So remember, it's always cosine first and then sine. So I'm looking for the first answer here, which is 0. So cosine of 90 is 0. So x is 3 times 0, or x is 0. Okay, we'll do the same thing for y, except for this is r sine of theta. So y is 3 sine of 90. Okay, so sine of 90, that's going to be the second answer, which would be 1. So 3 times 1, so y is 3. Okay, so we're describing the exact same point, just in two different coordinates. The first one was in polar coordinates, but that's the same thing as describing the same point as 0, 3. This one's just in polar, this one's just rectangular. If you compare them on the graph, okay, here's your polar grid. You've got a bunch of circles. There is your answer right there. Compare that with a rectangular grid. There's your answer right there. So they're in the same spot. It's just a different way to describe the same exact point. Okay, now go in the other direction, going from rectangular to polar coordinates. So what I'm going to need is r and tangent. Okay, and also be sure that your angle is in standard position. Okay, don't forget to do that part. 3, 3 to polar coordinates. All right, now to make sure you got your angle in standard position, you got to figure out, well, where is this point? Which quadrant? And since both your x and your y are positive, you're going to be in the first quadrant. Since you're in the first quadrant, your angle is already in standard position, so we wouldn't have to do anything once we found our angle. Okay, so to find our angle, we're going to use tangent of theta, which is y over x. And here they said x is 3 and y is 3, so this would be 3 over 3, which is 1. Okay, well, I don't want tangent of theta, I just want theta. So if tangent of theta is equal to 1, we're going to move tangent over, and it will become the inverse of tangent of 1, which that would be 45 degrees, or if you're going to write this in radians, it'd be pi over 4, either one. Okay, to find r, that is going to be r squared is x squared plus y squared, or the same thing as the square root of x squared plus y squared. So the square root of 3 squared plus 3 squared, or 9 plus 9, or 18, which we can describe this as 2 times 9. Break that apart, square root of 2 times the square root of 9, which that would give us 3 square root of 2. Okay, so we can describe this point 3, 3 in the rectangular system or in the polar system. So this would be 3 square root of 2, comma, pi over 4, or you could use 45 right there. So that would be our final answer right here. Now if you compare them on their different coordinate systems, they are talking about the exact same point. It's just a different way to describe the exact same point. Okay, now we're going to convert -3, 6, which is in the rectangular coordinate system, to the polar coordinate system. So first thing to do is figure out, where is this point? What quadrant is it in? So since my x is negative and my y is positive, so my x values are negative over here, my x values are positive over here, my y values are positive here, and my y values are negative here. So all of this would be positive for x, all this would be positive for y, all of this would be negative for x, and all of this would be negative for y. So it looks like we are in, if x is negative and y is positive, looks like we are in quadrant 2. Okay, so keep that in mind when you're looking for the angle, because that has to be in standard position. So we'll go ahead and find that angle. So tangent of theta, which is y over x. This is our x. This is our y. So 6 over negative 3. So that'll give me negative 2. Okay, I don't want tangent of theta. I just want theta. So we'll take the inverse of tangent of negative 2. And that will give us, our calculator will give us negative 63.4. Now we've already said that our angle is going to be in quadrant 2. So we'll be over here somewhere. This is the theta that we need to get. But remember, if we're looking for the inverse of tangent, then that's only going to give us angles between negative 90 and 90. Or really just angles that are in quadrant 1 or quadrant 4. Well, we're looking for an angle in quadrant 2. Okay, so this is where we have to be smarter than our calculator. So the angle that they just gave us, this 63.4, I'm actually going to ignore that negative. So this little angle right here, that is 63.4. To get the angle in standard position, what I'm going to do is 180 minus 63.4, and that's going to give me 116.6. Okay, that's the angle that I need to use. All right, and then we're going to find r, which is the square root of x squared plus y squared, which is the square root of negative 3 squared plus 6 squared, which that's the same thing as 9 plus 36, or 45, and I can break 45 up into 9 times 5. Break that up into the square root of 9 times the square root of 5, and that's the same thing as 3 square root of 5. Okay, so this point, negative 3, 6, describes the same point in the polar system as 3 square root of 5, comma, 116.6 degrees. So this would be our final answer.